A front row seat. Okay, ladies and gentlemen, let's get to it. You know, I had, just the other night, I was talking to a friend, and I was telling them how my semester was going. I was talking about the autograder, talking about how, aside from a couple hitches, it hadn't, nothing too bad had happened. You know, I hadn't had to make any late night runs to the office. The students seemed to be getting through projects pretty okay. A little bit of friction, not too much. I said, things are going well. It's looking like we're going to make it. And we got too cocky. We got way too cocky, okay? Because the autograders crashed several times this week. It seems like every time I wake up, there's a big old negative 99999 on someone's commit. Someone broke it. And it's to the office for me, and it's always something dumb, okay? Something tiny that was causing problems. So that's what it feels like with this linking and this including and headers and all that, doesn't it? I'll tell you, I think I said this earlier, but it's very hard for morale when you want to be thinking about the interesting challenges within the assignment, right? You want to be learning SDL and experimenting, but you just can't get that include file to work, right? And you'd say Xcode, just grab, SDL2/SDL.h. And the headers seem to be right. The header paths seem to be right. Xcode, you know about it. You're auto-completing for me. Why can't you find the file? Okay? And I'll tell you, this friction you might be feeling, you are not alone. Okay? You are not alone. I feel it too. I felt it during the summer. When I was here, doing tests on the groundwork max, 2, 3 a.m., and I know how it feels. It's not fun, okay? It's exhausting. You feel some dread as the time slips by, okay? And I know how you feel, okay? I'm sorry that I couldn't get the recording done for you, the linking tutorials, stuff like that. I promised it Monday night, didn't come. Tuesday night didn't come. Tonight it might come. Tomorrow, it definitely will, if it hasn't then, okay? The autograder and all of that is eating up a lot more of my time than I thought, so I apologize, okay? It's kind of that pre-alpha first course curse. Can't get to everything. But I'll tell you, if we can't start getting some of these problems fixed, you're all probably getting an extension. Probably not going to be super big, but if it gets real bad, if there's chaos in the streets, we'll respond to that, okay? The good news is that a good number of students have gotten through. They've started getting points, and as more and more people get through, we'll try and provide you more and more tips to help the rest of you get through, okay? So don't give up hope, all right? You're trying to do something that's very hard. Any other student would give up in your position during the summer, right? You're just trying this on your own. But keep fighting, okay? You'll get through, and it's going to feel fantastic when you do, okay? You know that feeling. Hold on to that feeling. All right, so let's go ahead and talk about a quick game engine. This one might be familiar to some of you. It is Frostbite, okay? This engine, the famous engine of Electronic Arts, made by the famous DICE studio in Sweden, Stockholm. It was initially released in 2006. It was created by DICE. It has its own Wikipedia entry and even its own company website, okay? Not every internal engine has its own website. I'll be honest, to me, it feels like EA kind of wants to sell this thing, they kind of want to release it, make it public. Okay, you know why? You know, I look at the market cap of Unity. Okay, Unity market cap, $12 billion. Okay, what's the EA market cap? Anyone know? 36. If EA had been a bit faster, if EA had released their Unity and it took over like Unity did, that would have been a big win for them. They were a bit late though, but who knows? Maybe they can catch up. Anyway, I want to show you this brief video. Now this is from 2014, so this is a pretty old version of the video. The engine has advanced from then, but let's take a look. This is from EA themselves.
Frostbite's been in development since 2006, and there's always been a roadmap and a plan for Gen 4 and beyond. So I like to think of Frostbite as an evolutionary process, and Frostbite 3 is the next step in that evolution.
Frostbite 3 is a really powerful tool set. A gamer is going to experience a much more authentic, believable, and realistic-looking game.
We have one unified program where you can create content that will run on everything from an iPhone to a next-gen console. And now it's really coming online and enabling the game designers to do way more than they've ever been able to do before.
We spend significant effort on creating more dynamic and living environments.
Before, they would have to go to a lot of work to make a tree feel like it swayed in the wind. Now we give them the tools to create the tree, and we let the game engine control how the wind affects that tree.
Frostbite allows everything to work together. The waves on the beach, the wind blowing the whitecaps, even the clouds overhead all move consistently with the forces of nature.
You might see an explosion go off, you'll see the trees nearby shake from the explosion.
It's sort of subtle, but it creates this sense of seamless reality.
Okay, it's an impressive engine. Okay, this footage looks great, and this was, what, 10 years ago? All right, so impressive stuff for sure. The development experience. This engine is a little bit notorious. It has crushed a few projects, actually, within EA's catalog. This was designed by DICE for the kinds of games that DICE makes. And what are the kinds of games that DICE always makes? Yes. First-person, realistic, destruction-oriented shooters, okay? And you can kind of get a feel. This is a SIGGRAPH presentation. Yeah, they put a lot of effort into making really cool destruction technology, deformation technology, and making it all possible to run on a low-spec hardware like consoles, okay? You can see some interesting, right? So destruction looks pretty good. It's not nearly as complex as the mapping and the texturing would make it look. The geometry hole that's been punched is actually much more simple than all these bricks you see here, okay? There's a lot of trickery going on to make this performant and keep the vertex count down. Anyway, very impressive stuff. And what's really interesting here, though, is that this is actually kind of a, it wouldn't be an EA product if there weren't some interesting corporate shenanigans going on. One of the interesting things that happened, a number of years ago, probably 6 years ago, EA introduced a mandate. Thou shalt, if you are an EA studio, thou shalt use the Frostbite engine for your next game. Okay? And, right, this is great for first-person shooters, but sometimes it's hard if you're not making a first-person shooter, as the developers of Mass Effect Andromeda discovered.
All the idea, so much explorable real estate was BioWare's faux pas. The next one was 100% Electronic Arts' doing. You know they were coming eventually. Around this time, EA would start mandating that all their studios need to switch to DICE's Frostbite engine, as it is immensely powerful and doing the things it was designed to do, which was to run first-person shooters and not really much else. There were no solutions for things like inventory, party management, and just about everything you'd expect in an action RPG. Why EA thought this was a good idea is, I honestly don't have an answer. When everything is done in first person, or if you're playing a multiplayer match, you don't really need expressive animations from your main character because you tend to not see them. BioWare Edmonton, however, also had to use Frostbite for Dragon Age Inquisition. Well, they fortunately did create a lot of the systems they needed for that game, which did help out the Montreal team. There was still even more basic features and functions they had to make from scratch
for themselves. So I can tell you why this mandate came about. Anyone want to take a stab at it? Why would Andrew Wilson say thou shalt use Frostbite?
Isn't it pretty common with big studios when they work with like the larger engines that they'll like sort of work back and forth, kind of improving the engine sometimes?
Absolutely.
They want to improve the competition.
Yep. Absolutely. Usage provides for excellence, and excellence brings you usage. It's a snowball positive feedback loop, okay? And so if Andrew Wilson ever had designs to maybe one day commercialize Frostbite, or if he just wanted to make this engine better and so that they could have an internal leg up on their competition in the AAA space, you want more people using Frostbite, because the more people use Frostbite, the better Frostbite becomes. The more bugs get identified and fixed, the more interesting features and flexibility is introduced. And maybe one day you've even built up enough internal documentation that you make it external and, hey, Frostbite, now open source, now available for your next game project, and we're going to take a tax on your sales if you use Frostbite, right? And that's why, okay? It didn't work. It did not work, and the market's a bit crowded now for another engine of the type. Unfortunately, a lot of their internal teams have now moved on. So, for instance, Apex Legends, a really big hit EA game from the last couple of years, Battle Royale game, that's using the Source engine. I could not believe it when I heard it. They're using the engine from Half-Life 2. Okay? That is a fairly rare choice, and that's a fairly old engine. I think they have revamped it since. And for Jedi Survivor, Respawn Entertainment out in California, they used the Source engine for Apex Legends, and then they turned around and said, no, we're going to use Unreal Engine 5 for Jedi Survivor, which just came out. So imagine going to a game studio and every project is on a totally different engine. That's a little bit wild. They have an extremely talented team. These games were all very well received. Anyway, so it's really interesting stuff. But just keep in mind, okay, not all the problems a game engine faces are technical, okay? One big challenge that Mass Effect Andromeda faced, was that there were so many studios trying to use Frostbite under EA's umbrella that the internal Frostbite engine team at EA, mostly in Sweden, they didn't have enough devs. They didn't have enough support devs to run around to every studio and help them implement the features they all needed. There just wasn't enough talent to offer the level of support those games needed. And a few game projects really, really got wrecked because of that. Anyway, so keep this in mind, right? There's lots of interesting non-technical things that can affect a game's production and a game engine itself. Okay. All right. You're doing a lot of learning, so much learning. You're doing an amazing job in this course, so much so that the department has taken notice, and they're now wondering why one of their servers is basically on fire in the server room, okay? Yeah, I got a message from the DCO saying, hey, Austin, this GitLab instance we've been running is on its knees. And do you have any idea what's going on? Because we see these game engine strings under your account everywhere in the logs. I think it's kind of fun. The GitLab instance wasn't really that popular or that used before we started using it. And now it's working very hard at all times. Okay, the good news is that we're not going to get kicked off the GitLab instance, I don't think, okay? Because it's really Wild West time if we do. We're going to be hand grading your auto grade, okay? Nikhil's going to be up all night doing that. Sorry, Nikhil. No, we're not going to do that. We'd figure something out, and it'd be okay. But basically, I was able to make some tweaks that slow down the autograder a bit, but reduces pressure on the GitLab instance to try and keep it going until the summer hits. At which point I can do a lot of dramatic improvements to the autograder and how it works. A central queuing system is a big one. And the DCO team can put it on a better machine and give it more resources. Okay? Yes?
Is there any reason you chose to use GitLab over the GitHub? Because I've noticed with other GitLab projects through Umish, it's like the website itself is just slower than GitHub.
So GitHub itself is something we could do. I'm a little bit nervous about rate limiting from the central corporation. We could try, and that's something we might do if disaster strikes. But I kind of wanted to keep at least this first run of the course internal to Umich.
Yeah, I just meant for future semesters.
Yeah, we might try that. That could work okay. I think there's some permissions things we would have to deal with. But I think we might be okay. Anyway, that was scary when that email came through, but I think we're doing okay now. I apologize for the tardiness of the SDL linking tutorial. Like I said, I'm going to have that finished tonight or tomorrow. And I understand how frustrating the situation is. I hope you'll hold on just a little bit longer. I got some tips for you, and we just discovered this a few moments ago. If you've got SDL running and building, but it's not bringing up a window, there's some things that might be causing that. SDL create window has a final parameter that needs to have SDL shown in it, okay? And I mean, like, look at that right there. If you don't put SDL window shown, SDL will assume you want a window, but not the visible kind. What kind of default is that? Now, if anything, they should have an SDL window hide, right? And not... Anyway, choose your defaults carefully, people, and you'll have a much better time. You want to have an infinite while loop because we just saw this a few moments ago, but you can have the operating system trying to bring up a window, but your program actually ends or you escape before it can show up. So you want to have something like a while true loop or while running or something, and then SDL delay in here, okay? At least one frame of delay. By the way, don't use SDL delay. You should use helper SDL delay. Actually, no, don't use that either. You should use helper SDL render present, okay, 498. That's usually the last thing you do in a frame. Present the frame, you're finished with it, show it to the user. That will automatically do a small delay for you, okay? And on the auto grader, it will do the smallest delay possible so your game can run as fast as possible and not wait for someone to watch it and look at it, okay? Otherwise, on VSync, VSync monitors will actually slow down your game automatically because you don't want to run super fast, right? Like it's a human with human eyes. So anyway, there are lots of little gotchas here for sure. You may also want to have an event queue loop that looks like this within that larger while game loop. Basically, we're going to talk about this in just a bit, but what this is doing is this is draining the SDL event queue on that frame. It's kind of taking all the events out of the frame so that it can fill back up next frame. Some of those events are going to be really great, like did the player press the space bar? That's an event. Did the player click the X on the corner of the window? That's the SDL quit event. And so that is how you do inputs and stuff. We'll talk about that in a bit. I think on some platforms, if you don't drain the queue, you freeze, you get wrecked, okay? So be careful, all right? Nintendo accidentally released a PC build of a famous game, Pikmin. Has anyone played that game? Anyone heard of that game? Okay. I'm going to show you a very, very quick bit of a documentary on the topic. This is great stuff.
Pikmin, a GameCube exclusive by Nintendo, had a secret PC version only ever intended for Nintendo employees to see. But when compiling Pikmin for the GameCube, they made a mistake. Every copy of the game has a Windows PC version left on the disc. Although Nintendo never published games for PC, this was released officially without anyone realising it, and runs on most modern PCs. When first booted up, a system error appears, because it needs a file from Windows 98 in order to even run. When the file is added, the game boots up and actually runs. There's a game window and a window called OpenGL/Dolphin System, which shows a bunch of debugging text for developers. It's not always incredibly formal, as when turning on Rumble, the game outputs a message saying brrr. Stretching the game window makes it run at a higher resolution, but the HUD stays the exact same size. It can be played with just the keyboard, though some keys overlap with developer controls, like the spacebar being the A button, but also being the button that freezes time. Tab brings up a special menu intended for developers, with options to select a level, switch on debug displays, and more. Some models won't show up at first, but that can be fixed by switching from generator mode to game mode in the debug settings. Pikmin's bodies will show up when this setting is turned on, but it also enables debug text above their heads. You can play the game in even the challenge mode, however there isn't any sound and the lighting isn't perfect. Challenge mode works really well with the right settings, but crashes when time's up, probably because it can't save any data. Going back to the level select screen, the debug menu will let you unlock all areas and then pick a level, including ones that aren't in the final game, like test maps that we'll cover later in the video. When in-game and out of the menus, pressing Z will open the debug menu. You can select a different level, end the day, go back to the title screen, access the...
I'll let you watch the rest of it on your own time. The takeaway here is that you can think of building a game very much like building a building. You look across the diag at the new CSI building being constructed. You need to put up a bunch of scaffolding, right, to make that building safely, to make it efficiently, to make it right. And that scaffolding ain't necessarily cheap. You sometimes have to invest a lot of effort just to get ready to build the thing and test the thing that you really want to make, okay? Accept that and know that if you really enjoy building tools like that help your developers on the game make content faster or debug faster, all that stuff, then there are roles on big game teams that are purely about that, DevOps roles, okay? Another kind of interesting thing, we talked about the Sucker Punch leak at the beginning of the semester. It's a devastating leak. You know, the public knowledge gains a lot because we get to learn how these companies are doing, what they're thinking about, how they look at things. But it's very devastating for the people who are now have lost their spoils, right? There are no spoilers now. However, this is a really good instance of that because we now get a ton of public knowledge Nintendo would not have ever told us, and it didn't affect them at all, okay? I mean, it's many years after their initial sales window, and so they're fine. They didn't lose anything. Pretty interesting to keep in mind, okay? Yeah, scaffolding for buildings. Think of it like that. It's important stuff. Not the most exciting always, but kind of interesting. Okay, let me see. On Piazza, there's a common idea coming up that in general, there's this tension between the elegance of your code base and the performance of your code base. Have you felt that at all? I'm writing this code, and it's pretty clean code. I understand what's going on. There are no bugs, but it's not fast enough. So I have to write this data structure that speeds them up. But wait, now I've got bugs in my program. It's faster, but there's this bug. Oh, because I've got this grid data structure and I have to insert my actors, but oops, now I might forget to take them out, right? So you see there's this tension, and you'll find this recurring, right? That you want to make something fast, it's going to cost you, okay? It's going to cost you in terms of the complexity of your code. Sometimes it costs you elements of your design. You have to add constraints. For instance, there's no actor that's allowed to get larger than WH size, okay? W max, H max size. And that frustrates your designers, but gets you a lot of performance speed up, okay? That tension and those trade-offs are kind of the heart of engineering, okay? Decide what you want, decide what attributes you want in your product, and then you go in and you achieve those, and you sacrifice anything that's secondary, okay? And that is often just how it goes. Another thing you'll notice is typically optimization in games often happens toward the end of development, okay? Why? Well, it's because you can optimize a lot at the end of development, and you can make the code a bit nastier to work with, right? You can make the code harder to read, get massive performance gains, and you can do that at the end of development so that your game designers, your gameplay programmers don't have to mess with that nastiness, okay? So that's how it goes, right? Create lots of content, focus on dev time efficiency, and then at the end of development, you go in there, you hack things up to get super performance. That's when you're focusing on runtime efficiency, okay? And of course, if you ever want to have a super general game engine like a Unity, it's going to cost you. The code's going to be more complex. The performance not going to be as good as it could be. Okay? So keep this in mind. You're going to feel this throughout the semester. Everything comes at a price. Okay. A quick review of quiz 2. It was a hard quiz. Okay, and I want to make sure that you kind of get a feel for some of the harder questions. There was a pretty, actually, I think, I thought this was thoughtful, but some people might think it's a trick question. Hopefully not. Which of the following is the most reasonable use case for STD optional? Okay, so in lecture, we went over STD optional briefly. It is useful in situations where you have a data type that does not have a clear sentinel value for the context in which you're using it. Okay, so if you have a string variable, current sprite, that you might have set, maybe you didn't set, they're pretty clear sentinel values for that, okay? The empty string. Fantastic, okay? That's going to work, okay? For an integer variable, for HP that cannot go negative, right, then use -1 to represent your sentinel value not yet set, okay? For actor star, for any sort of pointer, you can use the null pointer value, okay, as a great sentinel for it. For the X position, there is nothing obvious that you can choose, okay? 0 isn't going to work because you can be standing at the origin of your world. You're at 0. That's a valid position. 1 is obviously no-go, but -1 is also no-go, okay? You could choose something like -999. That might be an unlikely position, but if your player ever goes there, and they might be able to, then you're going to get blown up. Your code no longer is valid. It doesn't work. Who knows what's going to happen next, okay? So that is a good scenario. Clearly the best here for a standard optional usage, okay? Okay, benefits of header-only libraries. Ease of use is definitely the big one, okay? We had a few students choosing efficiency. They're not going to build faster, okay? When you've got a binary, the compilation step has kind of already been done, and you've got your object file, you're just linking, right? So you get to skip the compilation. With a header-only library, you don't have any binaries you can just quickly link to, and so you have to compile it in with the rest of your code, and it's going to be a slower build, okay? And this security thing, I have no idea. That's just, I think ChatGPT might have given me that one. It doesn't make any sense at all. Okay, shallow copy problem. This is actually a pretty hard problem. You remember this with the pals? So, right, you've got pals here. There's just a bunch of code here. You're going to read it. And basically, it creates a template, okay? We create a pal template here, an evil pal, okay? And we're going to start doing some shallow copies. We're going to start doing some shallow copies here, right in here. Right, we make a shallow copy right here, so we have a new evil pal, and we customize its position a little bit. That's cool. And then we take that new pal, we put it in, we index it on its ID into an unordered map, I believe. Okay, this almost works all right. The problem here is that we've forgotten to update the ID. Okay, it's a really easy mistake to make. I made the mistake while programming this. I was thinking, like, I got to introduce a bug here that's a little bit subtle, and then I had a bug. Just writing the thing. So I'm like, oh, perfect. Yes. All right. And so what happens here is that basically every pal has an ID of 1, I think, or maybe 0. What is it? It's actually going to be, yeah, you're right. It's going to be, no, it's going to be 0, right? Isn't this 0? And then it gets incremented. So it's going to be 0. Anyway, they all get put in at the same location, and thus the number of pals in our dictionary is actually 1, despite creating 100 copies, okay? So anyway, yeah, that's a bummer for sure. Okay, question, container membership. This one got updated and fixed. You got points for messing this one up at the end, please. Right here, it's really, I regret putting these two samey lines in, because you can kind of use both of these to check whether, whether you're in or you're out. What does membership mean? So either of these would have been valid. It's just a silly thing I messed up. I got to take away one of these, and suddenly the question's easy. Okay, by the way, don't you wish you had all these? Wouldn't it be nice to have like a exist or a find that's just like gives you the object, I guess? Kind of does. What does it?
Yeah.
What? Huh?
Plus 20 has contains. And it's just
Well, contains isn't in here, though.
yeah.
I have to be careful because C++24 could break my quiz when it comes out. Okay? Then everyone gets points for that. If you think a question is deeply unfair and not reasonable, please reach out, okay? If you've got a good case, you're probably going to get points back, okay? Don't be too shy about that. It doesn't offend us or anything. I made plenty of mistakes in the first semesters of courses. Okay, here's a question that also needed update. This is a question basically where we're pushing a lot of objects into our courses to take next semester. A lot of really great courses. You should consider them for sure. Imagine how innovative is it to put advertising for courses inside of a quiz in another course. I think I should patent that. Okay, so what's happening here is we're doing a ton of pushes, like a really gigantic amount. And the question is, if we find that our pushback performance isn't super great, what can we do to improve that possibly? And then we iterate through them contiguously. So ideally, we'd like this to all be contiguous. And if we if we start putting all of our objects on the heap, just scattered around like trash, it's gonna be a little bit slower. Cache not gonna be so happy. Okay. And so this one on the bottom is clearly out. This one on the top is going to be out as well because I tested this and it basically breaks your code. Okay. If you use move inside of here, you get this really efficient move of the object straight into the back of the data structure. The pain here, where is the code? The pain here is that like this cool sounding course A and cool sounding course B variable, we use it down here. So you don't want to be moving that, otherwise things will get spooky for you really quickly. Replace pushback with emplaceback is, I think, arguably the best answer. It doesn't necessarily make your performance worse. The problem is it might not obviously make it better. So the wording of the question is maybe needing an update. For instance, a student pointed out, one of your peers pointed out that the implementation for emplaceback in the Microsoft Visual C compiler is just literally pushback. It's just the same thing. And so that's that does make the question a bit funky, not great, ambiguous, not great. I think not all implementations are like that on other platforms, but I haven't had time to go in and check. Anyway, that one's going to get reworked. We'll see what happens, okay? At the very least, it's interesting to think about. Pointer invalidation, this might be the hardest one on the quiz. Here it is. Basically, we've got this vector of ints right here. You can see them pretty clearly. We grab an address, basically to be a convenience pointer to just give us the player. Okay, give us the player so that we don't have to scan through and find the player's number over and over every time we want it. What happens, though, is that we've created this pointer. It's pointing into our vector, and if that vector were to grow, it would invalidate the pointer because it has to be moved to a new location on the heap where there's enough space for the additional doubled size of the vector. Also a thing that can blow us up and be a pain is the sort, okay? So we've sorted the vector, which means while we haven't relocated the buffer, we have moved around the objects on the buffer. Basically, this pointer is now still pointing into our buffer, but it's pointing at a different element. It's no longer the 0 actor, okay? So what's going to happen here is it'll get reordered in memory. It'll be 0, 2. A 2 will be where that 0 used to be, and where the pointer is pointing at, it's going to print 2, okay? Now, I feel for you if you said it's going to crash or segfault or we can't say for sure, because it feels like funky behavior. Like you should not be doing this, but it is pretty consistent, it seems. And so, yeah, now you understand what really happened under the hood. Hopefully, the future questions maybe will be a little bit lighter on quiz 3. Okay, remember you can drop your worst quiz, so don't worry too much if it was a big disaster. You'll be all right. Okay. Okay. Any questions, comments? All right. Okay. So last time, right? SDL really is the star of the show this week, and it's been a war for some of the students trying to get this thing linked, trying to get this thing building, trying to get your loot files to work. in trying to fight Xcode all the way, and sometimes Visual Studio and Make. Okay? And so what I'd like to do is I'd like to show you and talk to you more about what you're getting for all this trouble. Okay? Last time we talked about SDL and kind of what its purpose is, right? So imagine the horrors of SDL and getting it to link and include and learning its syntax and its calls. But now you have to do that for every single platform that you care about. And if you're caring about Linux, for every single distro, kind of. Okay? Complete disaster. No, we would like to just learn SDL as tough as it might be. Let's get SDL working. Then the SDL team is going to take care of all the other platform kind of native libraries for us. Okay? That's the idea. And it's very, very popular. It is very much industry standard, I would say. And it has a lot of fantastic games coming out of it, left and right. In fact, entire engines use SDL under the hood for things like window stuff and all that. We did kind of run out of time on the question of how do you use it, okay? Once you have things being included and being linked properly, once you've gotten things building and running, what do? Okay, what do you do, all right? By the way, how many of you are at that step? Like it's linking, it's including, it's running, okay? How many of you are still fighting against the abyss, trying to get the thing to build? Really? Only 4 or 5? Okay, the more hands go up. You know, the more of your hands go up, the quicker I do the recording, right? So, all right, no. I've got to get to it. It probably will only be for Visual Studio for now, though, but I'll get to it. By the way, if you are fighting hard and your current platform isn't working, like, try another platform. Before the semester began, I came in like 3 a.m., 4 a.m. here. By the way, parking is really easy at that time here, okay? I can park just out the door. It's great. And I got Windows displaying. I got my engine running with Lua on the Groundworks Max, and that felt so good. And the Visual Studio machines in here. So I know it can work. I know it can happen. Okay, so how do you use this? Okay, how do you use SDL? Okay, well, this is kind of hello SDL right here. This is kind of how it goes. Okay, so you got some sort of function. You know, call it from main. This is a big one right here. This signature. You forget the signature, you're going to get weird SDL main errors popping up. Okay, got to have the signature. I believe the reason they have the signature is because WinMain on Windows platforms has very specific wants and needs and desires. And SDL is going to try and fix up your main function to turn it into WinMain. But if you use the wrong signature, it fails. Anyway, we got SDL2/SDLH included. That should give us most of the SDL core library. We call an init function. One thing that's really interesting to me, super interesting, I'm not sure, I have to test it, but I'm not sure you actually have to remember to call this, because SDL has, like, I love it, but a lot of people don't. They have a technique called the lazy load. Anyone know what a lazy load is? What is it?
It's when you wait until the last minute to actually load the thing you need.
Yeah, it's like you wait until the last second to load something you need or to initialize something that's been called. Okay? What's basically happening here is that you can tell SDL to prepare the video subsystems, the event systems, whatever you want. Okay, the audio systems. Or you can just make a call to SDL create window. SDL will detect, oh, the user wants to create a window, but we haven't initialized the video system yet, so let's initialize that now. Okay, I love that from the UX perspective. Like SDL figures out what you want, and it just turns on the things you need as you use it. Like that seems pretty nice. You don't have to remember this function call. Why is lazy loading, why can that bite you? What's the problem with lazy loading? Why don't people like it sometimes?
You don't have full control over your code.
Yeah, you don't really have full control over like when timing happens. You still kind of do, but it's annoying. So maybe there's a performance hitch that happens when you initialize a certain system in SDL, and you want to guarantee that's going to happen during the loading screen. But oops, you're Bethesda, and you are having it hitch as you're loading into the scene, and the player's seeing the game chug to life, and it's just a hideous monstrosity. Anyway, okay, whatever. So you might be able to get rid of this if you want to. I might even tell you, give it a shot. I think the UX is better if you ignore it. Create a window, okay? You've got a handler here. Remember, that data type right there doesn't have any functions or data associated with it. It's a handler, okay? When you get that, basically it's a key. You can think of it as a key or an ID for the window that SDL is now thinking about and managing on your behalf, okay? So we're going to call create window. This has a few parameters. Hello, SDL. This can take an X and a Y, or SDL, you can give it the SDL window pose undefined. Oh, no, wait, don't do that. I think it's SDL window pose, what is it, like center screen or something? Yeah, centered. If you give it that value, talk about STD optional. Does anyone know what that value is? Anyone know? That's probably like a negative 999, because negative 999 is not a useful coordinate on most monitors. That is an OK Sentinel. Do you know what it is?
For STD optional is doing? Or?
No. What SDL window pose?
Yeah, it's if you look
center.
at define, it's like a shift really far.
Okay. Yeah. So it's some number that would never make sense ever for an X coordinate, a Y coordinate. Anyway, so they have Sentinels. That's what they're doing. Okay. Resolution, an X and a Y. We fixed an issue in the spec, which was like window size or something. Now, it's just using the same parameters that you had in rendering.config on homework 4 now, okay? And then this is the big one, okay? I've seen some code already that forgot to put SDL window shown here, okay? And you get blown up if you don't have that, okay? So be careful. I like to put the window, the while true here, SDL delay 1. This might seem a little bit familiar to a yield return null if you're from 494. This is kind of giving the rest of the application a chance to breathe. So it's not, it's an infinite while loop, but it's not going to lock up your program, okay? And I think this might be good enough, at least on Windows, to get a window showing up, okay? Because here's what happens. There you go, okay? You see it. On Windows, at least on my machine, it came up. On Mac, I think you might have to empty the event queue if you want to see it show up, okay? This has no error checking at all. And so you probably want to introduce some error checking, okay? And this is an example of doing that. You can check if SDL on bit returns a number less than 0. This is a pretty common approach in C. You'll have a C function that will return a number, and if it's anything beyond 0, then you probably want to learn more. And they'll give you a function to look up the previous error that was generated, okay? And you can print that, you can learn more. That is just very C, okay? And you can get out of there with a return if you want to, okay? Down here, since the thing you're getting is a pointer, you can check it against null or null pointer, and yeah, you should be okay. All right? Yeah, not too crazy. Not too crazy. Hopefully you can get to this as soon as possible, because it really does start to get fun from here on out. And yeah, we've got a window, but now what, okay? Well, you need some rendering functions to draw something, okay? You can say, well, if this was object-oriented, this type, SDL window, would probably have some great functions for you. And it definitely doesn't, okay? And that's how you can tell this is definitely a C library instead of a C++ one. And there you go, okay? So now in your interviews, you can complain about this and talk about why you prefer one style over the other. And there you go. That's the kind of conversation I think interviewers enjoy having, rather than the whiteboard coding stuff. And if you're talking to Stardock, like they've seen 1,000 Zeldas and 1,000 Metroids, so this is stuff they'd rather talk about, okay? Just saying, all right? Anyway, okay, following name conventions is kind of the name of the game here. Your code complete just ain't going to be as good as it would be if things were object-oriented, but it can still help you out, okay? Especially if you follow the name convention we talked about last time briefly. SDL, topic you care about, and then some sort of operation name, and you'll start to find stuff, okay? And you can scroll through the list, you find some good stuff. That looks good, right? SDL, topic, operation. Sometimes things are named in a really weird way, okay? And you're just not going to find it. You're not going to guess it, okay? And at that point, just ask chat. Like, hey, chat, I'm using SDL, C++. I'm trying to do X. Do you have any useful functions for me? Okay? And the answer often is going to be yes. Okay? And the only question is, what is it named and what are the parameters it needs? Okay? Here's a pretty fun one. You're not going to actually use this until homework 7, but on a homework. But this is a pretty fun one if you just want to mess around. It takes your render instance and it takes an X and a Y coordinate, and you can set the color via a simple function earlier. So you've got your window, but we can't draw directly into a window. We need a render that is associated with that window. So we can create that render, get a handle to it pretty simply. You just need the window reference, use -1 to grab the first driver it finds that works, and then 0, like, do we need these special properties? The homework, I think the homework tells you to use a few properties, like vsync and hardware acceleration properties. Just follow the homework. It'll tell you what to do. Interestingly, the autograder, when helper discovers that you're on the autograder, what it will do is it will strip out some of those. It will go in and manually strip out the vsync flag so you can run way faster. So hopefully you wouldn't need to worry too much about that. Okay. A question is, well, what are we going to see? And last time you discovered that, we're going to see nothing. Okay. And that's kind of disappointing. Okay. So the problem here is that SDL is using a very common, very cool technique. It's called a double buffer. Okay. It's not that crazy. The mission is to get past screen tearing, basically, right? This issue where timing is off, or you are drawing into a buffer of data while that buffer of data is being presented to the screen. And so half of the screen you see on the monitor is the current frame, half is the next frame, and it's just a huge mess. Okay, it looks horrible. Here's what happens kind of under the hood. You got multiple buffers here. You are writing, you're actively showing off one buffer, but whatever buffer you aren't currently showing, you're writing to the one that isn't being shown. Okay? And so when we set the render color, okay, 255, 255, 255, 255, that's white with no alpha or with no transparency. When we draw that pixel at the halfway point on our screen, it shows up, but in the buffer we're not currently showing. Okay? And so what we got to do is we have to call a function. This is usually done at the end of our frame called SDL render present. And we call that with our render, and what that does is that moves the pointer. We are now dealing with the buffer we wrote to, and we're now displaying that pixel that we wrote. Okay? Now, when we do any future draw operations, they'll all go on to the unused buffer, the non-active buffer. Okay? This is basically like a flip. You're flipping the pointer, and so this is sometimes called a flip operation. Okay? Here it's just called render present. In the assignment spec, you'll be told to use SDL render present 498. Okay? Helper SDL render present 498. Anyone have any idea why? No, you don't. Maybe?
Autograder.
Yes, that's right. Can you imagine what it might be doing?
Probably recording.
Yes, that's right. So when you call SDL render present, normally, right, SDL will just flip the buffer and now you're showing stuff on the screen. When you call my SDL render present 498, it will do exactly that, but it will also save your buffer to the disk in a way that makes it very easy to turn into a video file for the autograder. Okay? And that is how the autograder works. It has a big batch, a big folder of instructor staff frames, and your engine generates a folder of frames, and we check literally every frame one by one to make sure that they are all literally the same checksum. And if they're not, we know that something is off, and we fail that test case. We generate video footage to help you figure out what it is, and then we upload that to your grade report. Okay? Basically, whenever we're asking you to use a helper function, it's usually for an autograder reason. Okay? That's why. It's kind of hard to get the autograder to do what it's doing, and there are a few things we need your help with in your code to make that work. The first few test cases are basically They're pretty simple. They're just trying to make sure you're using the functions the way they need to and responding to a couple events. Okay. All right. Anyway, further drawing will happen here now. So if we use SDL render copy, or in particular, this would be render copy X. Would it be? No, this could be done with render copy normal. Now, hey, you've got an image up there. You do SDL render flip again, render present, and now we're showing the bunnies. Okay, showing your PNG. Cool. And then further drawing is going to happen on the bottom. Okay, notice that the pixel is still there, so we actually have to clear this buffer before we continue to draw to it. Otherwise, we could get in some trouble. Okay, and so we're going to improve our situation here. We've added more functions. We are now drawing the color, setting the color at the beginning of the frame, drawing our point. We are presenting that point, and then we're calling SDL delay. No, you do not have to call SDL delay. In fact, you really shouldn't, because SDL render present 498, the helper function you call, will delay automatically for you, okay? The proper amount of time, and on the auto grader, it will delay the minimal amount of time to make you go really fast, okay? All right, okay. Unfortunately, oh yeah, it worked, okay? You can see it, right? Very fun. It's really getting exciting now, okay? All right, there you go. So one question is, can you make it move? And the answer is yeah, of course. All right, so let's make it move. Here's what we've done. We've got this int position x variable. It starts at 320, which is the center position on the horizontal axis in our frame. And what we're going to do is every frame, we're going to increment that upward. And we're going to draw a point. Yes, but now we're using position x variable instead of a hard-coded value. Okay? And this is what's going to happen. You see that? That's not exactly what we wanted. It's a line. Okay? Why is this happening? What have we forgotten to do? I told you about just a moment ago.
Clear the renderer, or like switch back to the other button?
Yep, that's right. Right, we're not doing it clear, okay? When the frame starts, one of the first things you'll always do is clear the current buffer, okay? Because it's not going to get cleared by itself, all right? It's like, what's going on here, okay? And so we've added a little bit more code, okay? We are setting the render draw color, and then we're doing a simple SDL render clear operation on that render. Now it will actually clear the buffer, and it will clear it with what color? The color we specified, okay? So in this case, we're specifying the color black, 000255, and we get this nice window with a moving pixel. Oh, heck yeah. All right, and you can kind of see it a little bit better just like that, okay? A little bit subtle. Rendering images is what you mostly care about until homework 7, okay? You're going to need help to load images. You're going to need help from the SDL image library, okay? And the library, you're going to have to link that. You're going to have to get the include files, get that all downloaded. Good luck to you. You're going to load a PNG into an object called SDL texture, okay? And SDL texture is kind of a GPU side buffer that's going to store your texture data, okay? And you can use the image load texture function, which is just very nice and simple, isn't it? Render, give it the name, give it the relative path. This path is going to be something like resources / images / and then finally the name of the path. I'll be honest with you. So it's not the fastest operation to load a texture, right? It's got to be sent to the GPU. You got to read data from disk here. And so you don't want to be doing this every frame, okay? I highly encourage you, your style is your style, do what you want, but I do encourage you to create some sort of class that will kind of allow you to load things, but then once it's loaded, it will remember it for you and give you easy access without, basically cache it for you without forcing you to load from disk every time, okay? I really like to make little, I call them database classes, right? ImageDB, that's basically it, right? Create me a database, load me up a database of images, and I'm just going to grab the ones I want, all right? You can call this whatever you want. So GPU side image data, slow operation, you should cache it, okay? And then what you're going to do is you're going to use the function SDL render copy. We'll be using this a lot, okay? It takes the render. Everything takes the render, right? It's crazy. Hello text is the pointer to that texture that we loaded, okay? Right there. And then null pointer, null pointer. Okay, what are those two? I'll talk to you a little bit more about that in just a moment. But essentially, it is source rectangle, a source rectangle. Basically, what part of the image? Do you want a little part of the image? Do you want the whole image? Do you want half the image, right? Have you ever heard of a sprite sheet? Hold on a sec. I'm going to show it to you. Okay, here's a sprite sheet for Mario. Okay? You see how Mario's sprites, right? This is one image, but there are a lot of sub-images inside of this. And often that's a really good thing for efficiency. Sometimes you want to just grab a small sub-image in there. And this allows you to do that, the source rect. It's an SDL rect data type, which is basically an X position, a Y, a width, and a height. That defines a rectangle, okay? And so, but if you provide null pointer, you're saying, give me the whole image. I don't care what size it is. I don't care at all. Just give me the whole image, which is reasonable, okay? The second one in null pointer, the second null pointer is the destination rectangle. Now that's a big one, okay? You're gonna have to customize that rectangle a lot, that SDL rect. You're gonna have to say, okay, I've got my image, but where do I render it on the screen, okay? Okay, what X position, Y position do I want it on? How wide do I want my character to be? How tall? And with this ability here, this parameter, you can move objects, translate, but you can also scale objects, okay? So it's going to be important for you. All right. And then you do SDL render present, and that's what you end up with. Oh, heck yeah, right? Basically, we just said, load up the bunny image and just make it the whole screen, okay? That's what null pointer means. Just make it fill the whole thing, okay? Cool, looks good. There's a bit of a problem, though, because the window is frozen solid at this point, all right? And first time I was ever using SDL, I was like, well, this is cool, but like, oh, right? It feels like it's almost there, but it's also broken. What's going on here? I can't even click X. I can't even move my window. Okay? All right, so what's happening? I even have a delay in there. It's not working.
I had this issue on Mac when I wasn't doing the full event.
Yeah, it's that event queue that I told you about, okay? Right? We need a smarter loop, and we need something that's going to drain the events coming out of our event queue, okay? So the event queue, it's basically, if you think about what the SDL team had to accomplish, the STL team is thinking to themselves, gosh, well, we have to find some way to give our developers the events coming through, okay? When the player presses the space bar, we have to have some way for the developer, the game designer, to find out about that, right? When the player moves the window, when they click X on the window, there are so many events that could happen, okay? If we're on mobile, we could get a notification event coming through, okay? If someone's using the DDR dance pad, someone could dance, and we have to have those input events come through. Okay, so what do? They said we're going to have a centralized system for delivering events of any type to our game developer. And this is that system, the event queue. Here's what happens. Okay, a frame is happening, and the player presses the space bar, or they click, right? Or they drag the window. So SDL will detect that. The operating system lets SDL know, lets us know, okay? And so we get an SDL window event moved in the queue, okay? Now, that same frame, the player also pressed the right arrow key. So we've got an SDL keydown event. By the way, this event has some sub-event data, some sub-data that says, oh, it's the right arrow key, SDL scan code right, okay? And then it has some other events maybe. Other events also, the user somehow dragged the window and clicked the red X on the window corner at the same frame. Incredible. Did you know that some operating systems, I'm pretty sure, can support multiple mice being connected at once? Is that nuts? So SDL has support for that. So maybe this is possible. Pretty exotic frame, though. A lot happened on this frame. Okay, SDL quit is the event that comes through when you click the little X in the corner of the window. If you do not handle this event, if you do not detect it as it comes through and don't immediately quit the game with like exit 0, you will get timeouts on all of your sweet 0 test cases, okay? So be careful about that. If your engine is failing to detect the SDL user input.txt file that gets put next to it, then you'll also fail. That's going to happen if your working directory, when you launch, is not where it needs to be. It needs to be, I'm pretty sure, at the root of your project. Anyway, events must be removed by the queue by us, even if we're not going to use them, okay? And I'll show you how to do that in just a sec. Otherwise, we're just kind of jamming up the event queue, and we're going to freeze, okay? Here's how you do it. And actually, it's pretty darn simple, isn't it? But this is another weird C thing. Look at this function. Anyone remember physics.raycast from Unity? Okay, it's another one of those functions where the designer of this function is saying, we need to get multiple values out of this function call. Okay, now one value we get from the return type of the function call. This SDL pull event will return 1, I think, if there are more events available in the queue. Okay, and it will return 0 if it's out of events. No more events. This is basically saying then, keep calling pull event until we're out of events. We've eaten them all up. When you call pull event, it will actually pop the event out of the queue, okay? And it'll put that event into the next event variable. When you create this SDL event structure, next event right here, you send it in and it will get filled with all the nice information about that event that's coming through, okay? Coming through the queue. You can now check next event. Its type, right? Its data. There are a lot of properties on next event. You click next event dot, and you're going to see a bunch of stuff, okay? And so please check that out, and you'll find everything you need, hopefully. And if you can't find exactly what you need from an event type, ask GPT. It will point out how to get, for instance, the mouse position when mouse move event comes through, okay? Again, the tough thing here is not knowing that something exists. It's knowing what the thing is called, okay? It feels cheap. Frankly, I really love the fact that as soon as I have an idea in my head these days, I can be like, chat, AI assistant, I know this concept is in here. Tell it to me right now, okay? And I just get to move on. Get to think about architecture and performance rather than what the thing is called. Feels like magic to me. Programming's so much more fun these days. Anyway, you won't call SDL pull event. You're going to call helper, : SDL pull event 498, okay? And what that does, anyone know what that does? This is pretty cool, I think. A little bit snazzy. Yeah. Yes. Basically, when you call my version of SDL pull event, it'll do a pull event, but it'll do it after I have loaded in all of the fake events on that frame, okay? And those fake events get pulled, under the hood, it gets pulled from a text file right next to your engine called SDL user input.txt. If you download a test case, and by the way, on Homework 5 and beyond, you can download every test case now, pretty much, you'll find the input that gets fed in. You can put that input text file right next to your engine, and when it launches, it'll use that input, okay? And you can just watch the game play itself, basically. It's really, really fun stuff. Anyway, all right. This is basically how we create a ghost player to play through your game engine games on the autograder while no one is sitting there. Okay, so SDL pull event, right? This returns 1 if there are events, it returns 0 if none are left. It pops 1 event with each invocation. So just having this and just printing the type if you want is going to drain that event queue and you should be good to go. Okay, it should stop freezing. It should be a good time. Typically, you put this input and event processing at the start of your frame, okay? Remember, get the input from the user, then update your game state logic. Then once the frame is updated, everything is new, you can render that state to the screen. That's how we do it in the course. And that's the order, okay? Now, I think I'm going to click on it, right? Oh, it's no longer, it's great, okay? Wonderful. And it all works. It looks like a normal window, okay? You must use it, or the autograder will fail you. Yeah, that'd be a bit sad. It's going to happen, but yeah, move on. Okay, the event queue is a fairly common pattern. You will see it in some other places. If you're dealing with the Windows native API, I think a lot of things in SDL were based on things that the team liked from the operating system native APIs that they saw. This is the Pygame one. So apparently Pygame had a similar idea. You basically grab events out of Pygame's event queue. You can process what type they are. Maybe you can use a switch statement or something like that. And you can do what you got to do. Okay? How many of you have used Unity? You know the Unity input manager where you can just go input.getKeyDown? Oh, how nice, right? Mwah. The tough thing about an event queue like this is that while you can grab input events to detect that a spacebar is pressed, you can't really get that object to the other side of the code base very easily, can you? Imagine you have some gameplay code on the other side of the code base. That's like, if the player presses space, I want to do this. But meanwhile, the event is all the way over here in some other part of the code base. How do you get the event over across? Well, in this course, you will be making Unity's input system, okay? Literally, like, the same API, the same darn thing. It's going to act the same way, okay? Please look forward to this. One of the more satisfying things I made when I was building the course version of the engine. Have you built that part, Nikhil?
Yeah.
The input manager?
Yeah.
Wasn't that fun?
Yeah.
Very satisfying.
The entire homework 7 is satisfying because you just get to see like actual games.
Yep. Yes. So homework 7 is a really tough 2-week assignment. When you're done, you're like, this thing's Unity. Okay? We use some of the Love2D APIs, and there are a couple tokens and terminologies that are changed. So instead of find game object, it's like find actor. Or no, instead of game object.find, it's actor.find because we're using the theatrical terminology, okay? A lexicon. All right. So this beauty right here, input.getKey, right? This is coming, okay? Don't lose hope. It is on the way one day, maybe, okay? If you believe. And that's all I have for our intro to SDL. There's more to learn. There is a version of a render copy that's spicier, and I'm going to talk to you about that now. We've got about 20 minutes, then we'll take a break, okay? Toward the end of this assignment, you're going to be dealing with not just rendering big images. You're going to be dealing with things like pivot points. You're going to be dealing with rotations, with scales. You're going to have to deal toward the end with a camera, a moving camera. What happens when the camera zooms out? Well, actually, I think that's next assignment. Zoom, camera zoom. Yeah, that's next assignment. You don't have to deal with that, okay? Yeah, that math is a little bit funkier. But what I'd like to do, how many of you have taken linear algebra? Okay, all of you, you're required. How many of you feel like you understand linear algebra? All right, that's some of you, okay? I can't tell if I understand or not. I feel like a gameplay programmer being pressed into service here when I talk about matrices and linear algebra, linear transformations and all that. The thing to know is that this stuff is important. You got to know it. And especially when you take a 3D graphics course, which hopefully you'll do soon, this stuff is at the core of all of that. Okay? So you're going to learn a lot about this stuff. Refresher if you've forgotten. Anyone play Yoshi's Island? Super Nintendo or Game Boy Advance? One really funny thing about Yoshi's Island is that they have this really, it's kind of lazy in my opinion, this recurring motif where every boss is just going to be a normal enemy that Kamek flies by and sprinkles with magic, and it just makes them bigger for the most part. Now, I want to tell you that this was not always a lazy thing. Like, this was really cool to see this. on a lot of the 8-bit hardware. I think even the Genesis maybe struggled with this. Maybe. No, they had games like Gunstar Heroes, so they probably didn't. This was pretty rare. And when people got to the 16-bit era, to see sprites that were scaling, squishing, and rotating and bouncing, right, looked super cool. That was crazy, okay? And so, yeah, kind of lazy today, but cool and pretty rare in the 90s. And so, people were down with it, okay? Now it's like, as soon as you see a big version of an enemy you've already seen and fought, you're like, okay, the developer is officially out of time to finish the game. And now they're just rushing to finish, and so we're just going to get color palette changes on enemies and resize changes and shake your head, right? This is Nintendo, though. They must have thought it was really cool. Okay, when it comes to transformations, you see the idea of transformations everywhere. In fact, transform is a recurring word. It's a recurring term. Pretty much all game engines, they can't figure out what to call their entities, their actors, but they can all agree that transform is probably going to be one of their component names, okay? Transform tends to have position, rotation, and scale data associated with it, okay? And you can see that in Unity, but you can see that in Unreal. In Unreal, transform is one of the responsibilities of the glorious static mesh God component, which just does everything in Unreal, basically. In Godot, it is some data that is associated with any sort of spatial derived class, okay? And so you'll see that right there. It's a little bit hidden, but it's there, okay? And when it comes to 2D transportations, right, position, rotation, scale, there are basically three that we really care about here in 2D. And imagine that we have this scene right here, okay? And at 0, 0 in the center, we have our character. Now, our character's just chilling there. But imagine you want to move it, okay? You say, I want to move it to X, right? And how about -1Y, okay? You have a transformation, a 2D translation, okay? Not a position, a translation. Now, it adjusts your position. But the translation here, if you're using Godot, they use translation to mean position. That's the first thing that's going to trip you up when you move to Godot. It's a bit painful. Anyway, translation of 2, -1 here. Nothing too crazy, okay? And you can do that kind of thing. If you have an SDL rect data type, it's super easy to do this, okay? Take the X value on the rect and just adjust it by translation X, okay? And adjust the Y by translation Y, no big deal, okay? But let's say you want to spin the object, okay? Something like this. Let's do a 180 spin, okay, counterclockwise, right? This is a rotation of pi or 180 degrees, whatever you want to call it. And you can do that in SDL by basically just creating a double value and putting a degree number behind it. You're going to feed this in to a function called SDL render copy X, the extended version of SDL render copy, and it'll just do it for you, okay? It's kind of nice. I'm gonna show you the math behind all this. If this is too simple to be satisfying, just give me a few moments, okay? All right, and then let's say that we want to scale it, okay? So let's make it twice as big. Well, you can do a scale as well. Scale it to, you can do it with this code right here. So you've got an actor view rect, W, right? This is a rect data type, so it has an X, a Y, but also has a W and an H. And you can multiply by that X scale and Y scale value. In this case, both of these would be 2. But you can separate it by axis if you want to. And you will get a scale, okay? Yeah, not too bad. A quick note for those of you who have dealt with these transformation matrices before, typically you don't do it in this order if you're doing it all as part of one big operation. Right, so we basically did one frame where we translated it, the next frame we rotate it, the next frame we scale it. But typically you do it in a different order. Scale, right, scale the object, rotate the object, and then move the object. If you do it in a different order, all as part of one matrix transformation, you will get a different result, okay? You'll get a move, a translation out here, then the rotate will actually take you around here, and then the scale is going to be weird. Okay, it's not what you want. So, yeah, in case you watch this and we're freaking out, yes, there's my disclaimer right there. Anyway, all right. We need to talk about the topic of pivot points, center points. If anything's going to confuse you, moving things around in this homework, it's probably going to be this. Okay. Why are center points needed? What are they? How do we deal with them in SDL? Okay. Here's your actor right here. And this actor image file, that's actually it. It's okay, goose.png. Okay. And what's interesting about this image is that SDL considers there to be an origin, an anchor, a pivot point to this image. Where's the 0 point relative to this image? Do you know? Is it in the center? Would make sense. It's not, though. Where is it? Anyone know? Bingo. Top left. Top left. Boom, it's right there, okay? And, like, you kind of get it, right? You kind of get why they chose this, right? It's going to make it pretty easy to align things to, the grid, the window, so it fits perfectly. And, the math, if you want to just tile things across, is going to be really nice because of this. Oh, it's not great, though, for characters representation. It's not great. Okay, this is the pivot or center point, as SDL calls it. I think Unity does call it the pivot point. When you're in Unity, when you're dealing with UI stuff, you define a pivot point. It's set as 0.5, 0.5 in the middle. Anyway, over here at this far point on the bottom right, we have the width point and height point. So however big this image is, or width and height, that's the point it's going to be in pixels, okay? And this kind of stinks. No joke, and I'll show you why, okay? Well, actually, tell me why. If we leave it like this, we're going to be in for a little bit of pain. It's going to be a little bit awkward for us. What's the problem?
You'll have to keep making offsets to center the image where you think it should be.
Yeah, if we want to center the image anywhere, we're going to have to do some math that's just a little bit unfortunate. Lots of offsets, they'll make things look ugly, might get us into bugs here. If I tell my goose to render copy at this SDL rect, 00 WH, okay? Right, this is basically just saying render the full goose image, render it at 00, right? You expect the goose to be centered right here. That's what you want, right? Not going to happen, all right? We give it our render, we give it our texture pointer to the goose that we're caching, right? We give it null to say we want the full goose, and we give it our destination rect. This is an address to the destination rect, don't ask, okay? And we're going to put it right there, right? No. This is what we get. Oh, what? What happened? It's all messed up. It's half off the screen, okay? Right? But here's what happened. Basically, what we said was take the pivot point of the goose. This is where the goose is considered to kind of be. And put that at 0, 0, 0. Okay? So that really stinks. Dang. Okay? What are we going to do? Well, you can kind of mess your code up to make this work. So here's something you can do. You can go up to your X and Y calculations. You can basically say, I want half of my goose. Let's move it like to the left, half of my goose's width. Let's move it back up, half of my goose's height, and we will get what we kind of wanted. When we do this, we're kind of pretending our pivot point is in the center, and we get this, okay? That kind of stinks though, right? Now our weird X and Y calculation is all funky. It's not as elegant as it could be, okay? It's kind of nasty. So here's something we can do. We've been using the default vanilla version of SDL render copy, okay? But there's a souped up version you're probably going to want immediately, okay? And this is SDL render copy X. X! Sounds hardcore. A real gamer function, okay? And what basically has happened here is we've gained a few parameters. That's pretty much all that's happening. We still have the first 4 we expect and used last time, but now we have a rotation parameter. It's a double, okay, degrees, to rotate. I think this is counterclockwise. That's kind of counterintuitive. Wouldn't you expect it to go, anyway, yeah, clockwise, right? Anyway, we can give it a center point now. That is a point. So basically a vector 2, a tuple, two integers, pixel locations basically. And this is going to be in pixels and relative to the top left corner of that actor view rect, okay, that we are drawing. And then we can also give it some information to tell it to flip the sprite, render it flipped on the Y or x-axis. Now, this will cause you some heartburn a little bit later, but don't worry about it. You'll get through it, okay? Basically, you cannot give an STL rect a negative scale. It'll freak out if you do this, okay? Yeah. Anyway, yeah, extended, shiny, great version, okay? Center point is what we care about. This is how we can manually adjust our pivot point, okay? So take a look at this. We now have a destination rect, which is 00WH. Great. That's really nice. That looks great. We now have a pivot point that says half of our width, half of our height, okay? When we do this, when we feed that pivot point in, okay, we're basically creating an official pivot point, as far as STL understands it, at the center of our goose. And when we go and render this, it's going to appear right there, just like we expect, okay? So now our character's kind of all set up, and it's feeling good, okay? But there's a bit of a problem still. It's like this still doesn't look quite right, because if you think about it, in a game with this perspective on the camera, we really kind of want the character's boots, the bottom of the character, to be at the position we're putting them at, okay? And watch this. This is just going to look a lot better when we fix this. But we don't really want the pivot point to be here. We want it to be down here, okay? And so we're going to fix that really easily by just saying, well, the width is in the middle, right? But our pivot point is actually at the bottom of our image, so H instead of half of H, okay? All right, it's now at the bottom, and when we run this, oh, nice. Doesn't that look awesome, right? Super good, okay? And this is, it looks great. The calculations and code is super easy to read. Probably won't mess it up. And this is basically how it works with our characters, okay? It'll even align the characters. So if you've got certain characters that are taller than others, right, it's going to align them perfectly, which is really nice, okay? All right. The camera stuff, I'm going to leave that as an exercise for you. It's not too hard. Basically, you'll need to adjust some of your coordinates based on where the camera is. When the camera's at 0, 0, like you're just adding and subtracting 0, 0 from things, which will do nothing. But as soon as the camera starts to move, you need to think about how you're going to add that movement, the position of the camera, in to calculate the final position of the character on the screen. Okay? And so you'll have to work on that. Okay? Experiment, and you'll figure it out pretty quickly. Okay? Think about your ASCII camera. Okay? Not crazy different. Now, one thing you should know, and this isn't the most important for your projects or your assignments, in STL's 2D rendering API doesn't really use matrices, to my knowledge, okay? But I think it's important to know that in general, these transformations, right, translation, rotation, scale, or scale, rotation, translation, SRT matrix, you can take those translation operations that we did and you can package them up in a pretty satisfying mathematical way as long as matrices do not mess with your head, okay? And they definitely mess with mine, but we're going to get through this, okay? This is optional for your homeworks, and if you want to use matrix operations, you're going to need to use GLM, okay? They have good support for that in GLM, but then you'll need to grab things out of the matrix and feed those things and results to STL as like floats and doubles and stuff. Anyway, this is definitely going to appear on the quiz, though, as it is pretty useful stuff to know for the future and to know for interviewing in general. As far as I can tell and see, when you're interviewing for engineering roles in the games industry, they really do like to hear that you know some matrix mathematics and some transformations and stuff like that. Yes?
My friend's got a job at it for a tool builder, and his review was just all vectors and matrices.
That's literally all it was?
Yeah.
Oh. I would not get that job. All right. Okay, so here is a matrix. Does anyone know what matrix this is? Yes? The identity matrix. And why is it called that?
There's nothing to vector matrix that you multiply with.
Yeah, that's right. Okay, This is a matrix, okay? This is an identity matrix, and when you multiply a vector by this matrix, you just get the vector, okay? This is kind of like a function, a default function that just returns to you what you give it, okay? Right? You can think of these vectors, right, with 3 components as basically being an x and a y, okay? Now that might be really weird to you. It's like, wait a second, we got three components in this vector, okay? Isn't this a 3D vector? Not quite, okay? Because while the first 2 are x and y, that 1 on the end is basically there not to represent a z value, but to make the matrix operations work appropriately, okay? This is called a homogeneous coordinate, and in general, you want this to be 1. And if it's not 1, you need to normalize it so it is 1 before you do any sort of operations on it. And you just kind of need to require it. You need to have it for the matrix math to work out the way you expect. If you want an x, y, z, then you're actually going to have 4 there because you need another 1 at the bottom of that too, okay? Anyway, when you do an operation here, right? So how many of you don't quite remember how the somewhat funky matrix multiplication works? Okay, it's very visual, right? I like to do this, okay? But basically what we're going to do here, if I recall from last night, is what you do is you start at the top of your vector, you start at the top row left of your matrix, you multiply by the values you see there, okay? So 2 times 1 gives us a 2. You then move, and you're going to add the next multiplication, okay, next combo. 0 times 4, that gives us a 0, and then 1 times 0, and that gives us a 0. So our final result for that little row there on the matrix, that component, is a 2, okay? And we're going to do the same thing with this second row in order to get our second number in the final output, okay? I messed up the thing. Typo. Should I fix that right now? Oh, hold on. Yeah, okay. There, we're back in it, okay? All right, anyway, right, 2 times 0 is 0, 1 times 4 is 4, and then 0 times 1 is 0, okay? And then the final one, 2 times 0, nothing, 4 times 0, nothing, 1 times 1 equals 1. And this is, I kind of like to think of it as kind of like a mask, right? You're basically using these 1s to select which of these numbers you want to keep and using 0s to wipe out the other components, okay? And get them out of the operation. Yes?
If you want just x and y, why don't you just use a 2D matrix? Like, no, sorry, just like 2 to 2.
Oh, a 2 by 2 matrix?
Yeah.
So if you do that, as far as I understand, a lot of the matrix math will blow up in your face, and it won't quite work out. You can talk to me afterward, and I'll try and get a better explanation for it, but we are running a little bit low on time. We got 4 minutes, oh God. Okay, think of the matrices as a function, okay? Matrices feel a lot more natural to me when I realize that they are a function that you can customize. You write new code in this function by changing the numbers inside, okay? And then you can apply inputs and you get outputs, okay? And if this is a function, the question is, well, what functions can we design? Can we design a function that moves our points, our vectors, okay? And the answer is yes. If you look at this matrix right here, as it turns out, if we put a number here and a number here, what we'll get is a translation matrix, okay? These are hyperparameters. So you are writing code, new code in this function, by choosing t of x to be something, or t of y to be something. That's a way to think about it, okay? The translation matrix, let's say that this is 5 and 1, okay? Now let's do that matrix multiplication operation again. We've got 2 times 1, that's good. The 4 gets blanked out by the 0, and then 1 times 5. We add 5 and 2, we get 7, okay? We come around here, 2 times 0, get blanked out by the 2. We got 4 times 1, that's 4, what we started with, but then we're adding 1, okay? We have just moved, right, and that gets us 5. We have just moved our 2 and our 4 vector by 5 and by 1, okay? We've just translated that 2D point, just like that. We've found a matrix that will move our object on any amount of y, x and any amount of y. And that just kind of blows my mind a little bit, right? It doesn't seem like it should be like that. It almost seems magical. And if you don't want it to be magical, you should take a course and talk to people who are better at linear algebra, okay? So they can prove it to you why this works. So that's great, but what about scale? Well, it turns out there are other places in this matrix where we can put some hyperparameters and mess with them to scale things up. Let's say we want to scale on the x-axis by 3, the y-axis by 2, okay? Let's do the math, all right? 2 times 3, it's going to be 6, right? Blanked out by the 2 zeros, so we got 6 there, okay? We got blanked out by the 0 here. Okay, we got an 8 here. And my goodness, can we already see it? It worked. It's like magic, okay? 3 times 2 is going to be 6, and then 2 times 4 is 8. So we've tripled our our x-axis value. We've doubled our y-axis value, and then our 1 is just going to come out as you expect, okay? And that's pretty nuts, okay? The next one is gonna blow your mind, and this is one I'm not sure. This is pretty gnarly here, okay? All right, this is usually where I run for the hills, personally, okay? But basically, what we've got here are more hyperparameters, and the hyperparameter we care about is the theta. This is like the rotation, degrees or radians, whatever you want. And this is our little grid right here. So this is where our current point is. And the idea is we want to rotate around the origin someplace like, around here. Let's rotate like 45 degrees, okay? And so how do we do that? Well, for 90 degrees, 90 degrees is fine. So that's pi over 2, okay? Basically, 90 degrees pi over 2, we can kind of look at what cosine and sine evaluate to. Okay, so pi over 2, right? This is going to be a cosine value of 0, okay? So that becomes 0. Sine right there is 1, so it's going to become -1, okay? Sine is 1, so this becomes 1, and then cosine again is 0, okay? And there's no way this works out. It just seems so arbitrary. But let's go ahead and see. Get blanked out by 0, okay? -4, okay? And 0, all right? So we've got a -4. Down here, 2, 0, 0, so we've got a 2, okay? And then down here, right, it's just 1, these two being blanked out by the zeros, okay? -4, 2, 1. Does that feel like a 90-degree rotation? It actually kind of does, okay? And when you chart it, it's like, yeah, that looks like a 90-degree rotation around the origin. And that's crazy, isn't it? Okay, but this is the really cool part. All these translations, right? The choppy GIF. Just don't ask me for a proof, okay? The really cool thing here is that all of these operations can be composed into a single packaged matrix. We can take these operations and put them all into that identity matrix. Okay, we got the translation matrix here. You remember our tx and our ty. That'll move things. If you multiply your x and y vector by this matrix, it's going to translate. It's crazy. Okay, but we can also add in the scale at x and y, and then we can add in the rotation. Now, wait a second. We've got scaling values in these elements, these cells here, so we do a multiplication, okay, to keep them together, to package them together. And now we have our SRT, scale rotation translation matrix. This is sometimes called the transform matrix, okay? And I think officially it's typically called the 2D affine transformation matrix. Affine basically says you're not losing the value of you're not losing any parallel lines. You're keeping your objects, your geometry, kind of relative to each other. And so, if these parameters, when you look at the hyperparameters of this matrix is just a function, okay? It has tx, ty as parameters. It has a rotation degrees a parameter, and it has x and y scale parameters. And wouldn't you know it? Look at that. Does it look familiar to you? Okay? And so the big takeaway here is that all those transform components, like this is why it's called that, okay? This matrix is very important to game engines and graphics, and it's very, very fun matrix, and it's a mainstay. It's a classic. It'll show up in all your engines eventually at some point. One interesting thing is that you probably won't have a whole lot of matrix stuff happening in your engine, but you can expose these matrices, and you can allow users to set them if you want. Some engines, like Love2D, give that matrix to you as a means of allowing you to move objects, move actors, move cameras, okay? And it's pretty fun stuff. It's pretty cool. And what amazes me is like how you discover these designs in the first place. That is very interesting to me. And there are some very good channels on YouTube that can walk you through this kind of stuff. There are a lot of great resources online. And there are a lot of great proofs that you can find that will kind of walk you through how discovering these can be natural, okay? Anyway, does anyone have any questions? I'm 4 minutes over into office hours. Everyone, thank you so much for coming, and we're going to see you next time. I promise tonight or tomorrow we're going to have at least a Visual Studio recording showing SDL getting that window open from scratch, everything downloaded, getting Visual Studio set up. I'm going to have that for you soon. Do the best you can in the meantime, hopefully we'll get across the finish line, okay? See you next time. What's up?
I was just wondering if it was more like optimized to use the matrix correctly instead of using the functions we're talking about.
Well, in SDL, if you're using
Yeah, because this is what I did. I finally got a function is I had to do this to get it because I don't know what you guys are running. I use PS code, but I had to do this, like be very, very strict on it going here. Also,
can you just set this
I can just post it. So here's that, and then yeah, right. So and then here's this. I downloaded when it came to GLM or SDL. I downloaded this. So we go here. You download this.
Hold on. This is the
Windows,
as we
need to download this, and then you also
like even to get it to build on Linux,
yes,
you need a Windows library.
Well, no, because you gotta just include the headers. And I threw all the headers from SDL, image, TTF, and all those into one.
I had to, like copy over my frameworks folder.
Yeah,
it's not the same thing, but I had to copy over my frameworks folder outside my library.
Also, I'll show you I'll just show you how.
How to do everything related to the
Well, that's how I did.
Are you going to have a lecture on spatial hashing?
Yeah, and then this is how I have it. So, shit.
You mean like the region technique?
Yeah.
SDL,
probably
include.
Okay, so I should teach that.
I think that's a reasonable thing to teach in the discussion. If you got other stuff, though, I can teach it.
Okay, do you think I should teach it this discussion or next discussion?
Yeah, I'll try. Yeah, it's literally a
I don't know. I feel like it's going to be most useful next discussion because at that point everyone will be grinding performance on
That's
That's right.
Definitely show you SDL and
I got an autograder question.
Okay, take care, everyone. Bye bye.